today's topic for this session is number series. Number series, it's a part of reasoning. Let us start to understand about this topic. It's a very basic topic. In every competitive exam in which the reasoning is a subject, questions have been asked from this topic, concept of number series, right? Before starting with the number series, first of all, there is a need to understand the different varieties of questions that have been asked in that. So primarily we can divide the question in three categories. The first category deals with in which we have to find the next term. We have to find the next term, right? Means a few terms are stated to us, right? We have to find the missing one or the next term that is inside that, right? The second variety of question that we have that deals with, we have to find the wrong term. We have to find the wrong term. Any sequence is given, right? Suppose 6 to 7 terms are given and in that one term is wrong, right? We have to identify that the term on which no pattern is being followed. And third type of question that we have, that is analogical number series. Analogical number series, right? In this type, one series is given and one more sequence is given. With only one term is given of that sequence, we have to find that the pattern that is being applied on the first series, we have to apply the same pattern on the second series and find the number of terms of the series, right? So primarily we have, in this chapter we have these three varieties of questions, right? Let us start to discuss one by one. First we take the first type of sequence in which we have to find the next term, right? Before starting with the different patterns that may be there, first we just take a few examples. Just start with the basic one. Suppose if I say 1, 3, 5, 7, 9, right? I have to find the next term. I can easily answer it. How? I can say that the difference is 2, 2, 2. It means I can say that the next term is equal to 11, right? It may be 1, 2, 4, 7, 11, right? Then we have 16. We have to find the next term, right? What I can say? Here I can say that 2 minus 1, 1, 4 minus 2, 2, that is 3. This is 4, this is 5. I have to find the next one. I can easily say 1, 2, 3, 4, 5. It means my next term, it should be 6, right? So I can say 6, it must be 22. Okay. Now here I want to tell you one thing, that sometimes we are not able to, sometimes few terms are given and we are not able to find a pattern. In that case, we apply the pyramidal approach. Again subtract 1, 1, 1, 1 and 1. Means after a pattern, some pattern must be there. After, if I just subtract in such a way, so after such subtraction, some pattern must be there. Suppose in this question we can make the pattern in the very first subtraction. Sometime after subtracting we are not able to make any pattern, right? In that case, again subtract in this way, right? If you are able to get the pattern, you can solve it. And if you are not able to get the pattern, again subtract in this way, right? So finally, after 2 or 3 aspects, you are able to get your answer. So this approach is basically named as pyramidal approach. That's named as pyramidal approach, right? So generally, when we are not able to find any exact pattern, so in that case, at that type of sequence we apply in order to get our answer, right? Suppose take one more example. Let us say 10, 15, 19, then we have 16, then we have 14, right? We have to find the next term. What I can say, 10, 15, 19, sorry, we have committed a mistake here. 19, it should be 22, 24, we have to find the next term, right? What we can say, 10 plus 5, 4, 3, 2, it means index it should be 1, so I can say answer is equal to 25, right? So the first type of sequence that we have taken, so these type questions are based on the first type of the number series, which are based on the concept of difference, in which if you have any series, the first approach that we apply in order to get the answer is, we just try to take the difference between the terms, two consecutive terms, and try to find an analogical pattern. If any particular pattern is made on that cases, on that base, we can easily answer our question, right? The second type of questions that we have, these are based on product. These are based on product, right? Few questions are very simple. Suppose if I say 2, 4, 8, 16, 32, I have to find the next term, right? I can very easily find out. Why? Because I know that 2 into 2, 4, 4 into 2, 8, 8 into 2, 16. It means 32 into 2, 64. My next term is equal to 64. Without any problem, I can answer it, right? Sometime it may be in the format of, let us take an example, 4, 2, 2, then it's 3, 6, right? And then it's 15. I have to find the next term. I have to find the next term. Now when I observe it, now it's a very standard type question here. Sometimes two terms are same. First it decreases, then every time it's going to increase, but in the place two terms are same, right? For that, in generally that pattern may also be checked here that 4, 2. It may be I have to divide by 1 by 2, or I can say I have to multiply by 0.5. 4 into 0.5 is equal to 2. 2 and 2, it means 2 I have to multiply it by 1. 2 into 1 is 2. 2 and 3, I have to multiply by 1.5. Then I have to multiply by 2. Then I have to multiply by 2.5. It means further I have to multiply by 3. So it should be 45. The answer to this question is said to be 45. I hope it's clear what we have done. Very simple thing. 4, 2, 2, 3, 6 and 15. That sequence is there. I have to find the next term of the series. So what I can say, I have just multiplied 4 into 0.5. We are getting to be 2. 2 into 1, 2. 2 into 1.5, 3. 3 into 2, 6. 6 into 2.5, 15. And then I have to multiply by 3. Right. It should be 45. Here I can say answer to my question is said to be 45. I hope it's clear. Okay. Let's take one more example. We have 4, 20, 80, 240. I have to find the next term of the series. I have to find out next term of the series, right? Here what I can say that 4, 20, 80, 240. 4 into 5, 20. 20 into 4, 80. 80 into 3, 240. It means next time it must be 2. So 240 into 2, that is said to be 480. So answer to my question is said to be 480. Here I can say that my next term of the series is equal to 480. 480 becomes my answer. Right? Just take one more example here. Suppose here I give you 2. And it's given as first term is 2, right? Second term is given as 6. First term is 2. Second term is given as 6. Third term is given as 12. Then it is 20. Right? Then it's 30. I have to find the next term. First term is 2. Then 6, 12, 20, 30. I have to find the next term. Now one observation that we can make, we can say that 4, 6, 8, 10. It means next it should be 12. It should be 42. That you can make an observation here. Or you can also say 2 would be taken as 1 into 2. 6 is taken as 2 into 3. 12 is taken as 3 into 4. That is 4 into 5. And this must be 5 into 6. So next term would be 6 into 7. Here I can say that 6 into 7 is equal to 42. Hence I can say answer to my question is said to be 42. That becomes my answer. Okay. Let's have one more example here. Suppose one sequence is given to you 2. Then it's 12. Right. Then it's given as 30. Okay. Then it's given as 56. I have to find the next term of the series. Right. Now when I observe it, the first approach, if you are not able to find anything, you may go for the pyramidal approach. 10, 18, 26. Then I can say 8. It is 8. It means next must be 8. It must be 34. When I add 34 here, it must be 90. That becomes my answer. The pyramidal approach is very important because it's not given in any of the book, right? But that is a very suitable approach. If you have to solve any question on that based on the concept of the number series and you are not able to find out what pattern is being followed, In that case, if you go by this approach, it's very easy for you to answer. Sometime it may happen, you have to go further also, right? But after a stage, you must be in a position to get your answer, right? Let us take one more concept here. Suppose I said 2. 2 may be taken as 1 into 2. 12 is taken as 3 into 4. 30 is taken as 5 into 6. 56 is taken as 7 into 8. It means the next term should be 9 into 10. It should be 90. Hence, answer to my question is said to be 90. 90 becomes my answer, right? I hope the idea is clear. So that is the second type of question that we have, in which we have taken the concept of product, in which the questions of number series are based on the type of product. Let's take the third variety of question here. Squares and cubes. Squares and cubes. Sometime the difference between the two consecutive numbers is in the form of a square or a cube. Suppose 1, 2, right? Then it's given as 6. Then it's given as 15. Then you have 31. We have to find the next term of the series, right? When I observe it, so I can say 1 and 2, the difference is 1. 2 and 6, difference is 4. 6 and that is 9, right? Similarly, 15 and 31, that is said to be 16. That I can say, right? If you are in a position to get that, it's a square. I may say the next term must be 25, right? And hence I can say answer must be 56. That's your answer. And if you are not able to observe what this pattern is there, you may just apply the pyramidical approach. 3, 5, 7. Now I'm able to get a pattern 3, 5, 7. It means it must be 9. When it's 9, it must be 25, right? It means that my answer to this question is said to be 56. 56 becomes my answer, right? Sometime it may be adding something in that. Suppose first term is given as 2, second term is given as 6, third term is given as 12, fourth term is given as 20. I have to find the next term, right? So I may take it as 1 square plus 1, then 2 square plus 2, 3 square plus 3, 4 square plus 4. My answer is there, right? So next I can say 5 square plus 5, answer is 30, right? Or it may be, question may be 1 square minus 1, it may be 0. 4 minus, it may be 1 square minus 1, 2 square minus, the question may be any of the pattern in which we have to somewhere be care of that. It may be either it may be in the form of a square, there a difference